Hi everyone. I'll work through this test for you, help you study. And these first three equations are absolute value equations, and we isolate the variable, split into two equations, solve, and check. So I've got y plus 3 equals 17, or y plus 3 equals negative 17, and just solve both of them. And I've got y equals 14 or y equals negative 20. And when I check 14, absolute value of 14 plus 3, does that equal 17? That's 17. Absolute value of 17 does equal 17. And when I check negative 20, it's negative 20 plus 3 in place of y here. Does that equal 17? And it's the absolute value of negative 17. And that is, remember when you take the absolute value of a negative, you make it positive. So that works too. So these are both solutions. Don't forget absolute value with equations. You've got to split into two when you're doing these. And this one, I'm going to subtract 8 from both sides, and I have the absolute value of 4x minus 3 equals negative 7. And boy, as I look at this, when I take the absolute value of something, it will never be a negative number. So there is no solution to this equation. So I'm just going to stop there. But when I saw absolute values isolated and it equals a negative number, there's no solution. So this one I am going to split. I've got 3x minus 1 equals 2x minus 4, or 3x minus 1 equals negative 2x plus 4. Notice I changed the sign in front of 2x, and I also changed the minus to a plus. I changed everything about that. Went completely opposite. So now it's time to solve both. I'll solve this one first. I'm going to subtract 2x, and I have negative 1, 3x minus 2x is x, so x minus 1 equals negative 4. I'll add 1 here and add 1 here. X equals negative 3, which I'll check in a minute. I'm going to add 2x to both sides here because that's a negative, so I'll add 2x here. I've got 5x minus 1 equals 4, and when I add 1, I've got 5x equals 5, and when I divide by 5, I get x equals 1. Now it's time to check those two, this one and this one. I'm checking up here. Absolute value of 3 times negative 3 minus 1. I'll be right back here. All right. I'm back. So I got the absolute value of 3 times negative 3 minus 1. Does that equal 2 times negative 3 minus 4? So that's negative 9. This part's negative 9. Negative 9 minus 1 is negative 10. So absolute value of negative 10. And this is negative 6 minus 4 is negative 10. Now the absolute value of negative 10 is 10. 10 does not equal negative 10. X equals negative 3 is not a solution. It's extraneous. And I'm going to check x equals 1 into here, and that's the absolute value of 3 times 1 minus 1. Does that equal 2 times 1 minus 4? And 3 times 1, that is 3 minus 1 let's see, I'm just looking real quick. That's 2, the absolute value of 2, and this is 2 minus 4, which is negative 2. Does 2 equal negative 2? That does not. So that is not a solution either. If we were going to have a solution, if I did all my steps in the equation right, if we were going to have a solution, it would have been one of these two. So this is the second time we're going to write no solution, because our 2 that we found for possibilities are extraneous. Alright, well, number 4. Alright, we're going to solve the inequalities, and we're going to simplify that and then put it on a number line. So I'm going to add 14 here and add 14 here. And I've got negative 6z is less than negative 13 plus 14 is negative 18. Negative 32 plus 14 is negative 18. Then I'll divide by negative 6, and I'm going to switch that thing around and have z is greater than 3. So there's my simplified inequality. I'm not going to get too fancy with this. I'm going to put 3 on the number line and open circle on 3 because it's just greater than, and a heavy arrow to the right. Alright, well, number 5, I'm going to add 4x here, add 4x here. I've got 14x minus 7 is greater than or equal to 21. So I'll add 7, add 7. We're looking at 14x is greater than or equal to 28. I'll divide through by 14 here. And I have x is greater than or equal to 2. Okay, I want to circle that. And x is greater than or equal to 2. I'll put 2 here. I'm going to put a closed circle on this one. And heavy arrow to the right. Alright, there's the simplified inequality, and here is the number line. Alright, so follow instructions when you're taking your test. The instructions will look just like that. Now this is a two-parter. It's an OR problem. We solve each part separately. So I'm going to add 6 to both sides. I got g greater than or equal to negative 5. Let's solve this one. Let's subtract 4 from both sides. And I got 2g is less than negative 19. And I'll divide by 2. I got g is less than negative 9.5. Okay, and this is an OR. G is greater than or equal to negative 5 or less than negative 9.5. Now negative 5 would be a little further to the right than negative 9.5. Greater than or equal to negative 5. So I'm going to, or you graph everything. Now and you just graph the common parts. And less than. So I leave that one like that. Okay. And then number 7. I'm going to subtract 8 from both sides, or actually 3 sides, from the middle, right, and left. And I'll put my inequalities just like they appear right here. What's left in the middle is 4x. 32 minus 8 is 24. Negative 12 minus 8 is negative 20. I'll divide by 4. Negative 5 is less than or equal to x, which is less than or equal to 6. Okay, that is simplified. Put that on a number line. I'll put negative 5 here. I'll put 6 here. I need closed-in circles here and here. So less than or equal to 6, greater than or equal to 5. That goes right between those two. This is an AND. Or AND. Number 8. This is greater. How about that? It's an OR problem. 4x minus 7 is greater than 13, or 4x minus 7 is less than negative 13. So you switch the inequalities direction and you change the positive to a negative when you rewrite the second one for the OR. So let's add 7. I got 4x is greater than 20. Divide by 4. I have x is greater than 5. And let's add 7. I got 4x is less than negative 6. Negative 13 plus 7 is negative 6. Divide by 4. X is, this is OR, less than negative 1.5. And here's negative 1.5. Here is 5. Greater than 5 is that direction. Less than negative 1.5 is this direction. So here it is. Okay. This is less than. That's just my goofy way of remembering, but less than, you use, this is an and when I have an and, I like to take it out of the absolute value and write just the less than or equal to 17. Then on this side, write this symbol, same direction, but negative 17 over there. So I'm subtracting 2 from both sides. I got negative 19 is less than or equal to 5z, which is less than or equal to positive 15. Divide by 5 in all 3 places. That gets the z by itself. This is a 3. 19 divided by 5 is negative 3.8. Negative 19 divided by 5 is negative 3.8. So I'm going to put negative 3.8 here. I'm going to put 3 here. This is an and situation, so I am going to shade right between those two. You got to be less than or equal to 3, and you got to be greater than or equal to negative 3.8. Okay, number 10. Circle the linear functions. This one's actually in standard form already. X is to the first, y is to the first are not being multiplied together. This one is not. The x to the second, y to the second, whenever you have some other exponent than 1, it's not. Now this has a third power in it, so oops, let's not circle that. Do not circle that one. Okay? Do circle this one. That's in y equals mx plus b form, slope-intercept form. This f of x also just means y, so don't look anything more into that. So that is a linear function. And this one right here is not a linear function. You cannot divide by your variable and have a linear function. Now, number 11. For 11 and 12, use the equation 3x equals 4y minus 24. 3x equals 4y minus 24 requires us to, that's a y, take 3x minus 4y equals negative 24. So it requires us to get, standard form is ax plus by equals c. We do not have to change anything. We don't have to multiply through by negative 1. But if we had a negative value here at a in front of x, then we would multiply by negative 1 and change all the signs. We don't have to do that in this instance. So 3x minus 4y equals negative 24. A equals 3, B equals negative 4, and C equals negative 24. So here's the standard form. Here's identifying A, B, and C. Next is number 12. We're using the same equation. I'm going to use the 3x minus 4y equals negative 24. And I'm going to set up x and y and use the intercepts. X is 0, y is 0. If x is 0, we're going to take negative 24 divided by negative 4. The c divided by b, and that is 6. If y is 0, we're going to take negative 24 divided by 3. And that gives us negative 8. It's the c divided by a gives us the x-intercept. So let's plot 0, 6. 1, 2, 3, 4, 5, 6. So there is the y-intercept. That's one of the things they asked for. And here is the x-intercept. It goes 1, 2, 3, 4, 5, 6, 7. Negative 8 is right there. And then just, whoops, I kind of missed there. Let me do a little bit better than that. Draw the line between those two. So graph, here's my intercept table. Notice I put the 0 in for x first and then the 0 in for y second, and then I calculated what each of those would be. All right, we're winding down here. Number 13, find the slope of the line that passes through negative 2, 7 and 3, negative 1. All right. Miss Salyer is going to be watching for this. She told you to label your points. I'm writing down the slope formula, which you need to know. y2 minus y1 over x2 minus x1. So when I do that, I'm looking at negative 1 minus 7 over 3 minus negative 2. Negative 1 minus 7 is negative 8. 3 minus negative 2 is 5. So my slope, I'm looking at negative 8/5. Okay. Number 14. The table shows the distance traveled by a car after each time, given in minutes. Find the rate of change in distance for the car. So in 15 minutes they drove 20 miles. I'll be right back. All right. Find the rate of change in distance of the car. So the rate of change is constant. If you'll notice, the minutes are going up by 15 each time. The distance is going up by 20 each time. So we can do the y2 minus y1. This kind of call this the y, this the x, and I'll put y1 here and y2 here, x1 here, x2 here, and I'm going to take 40 minus 20. This is the rate of change over 30 minus 15, and that's 20 divided by 15, and those are divisible by 5, so that's 4 over 3. That's approximately 1.33 miles per, this is miles here, that's the distance, and this is minutes here, miles per minute. Okay guys, take care, study for this test. You won't need good luck, you will have it in your own hands.